Thanks for this introduction. Actually, I'm a professor of computer science, so usually I teach in this kind of a setting. I teach at the University of Applied Sciences, so it's not very sophisticated, but more practical in an approach. It's applied sciences. So why am I doing something with flight data? What is my motivation? Well, I used to be working at the German air traffic control for about 12 years, and I was doing software development for them. And the software that I built was regarding flight data and visualization and also monetization, so whatever. And after 12 years at the German air traffic control, I decided I wanted to do something else, and so I became a professor. And my main subject is computer science and agile software development. But my fascination for flight data is still unbroken, and so when I found out that there's the Opensky network, I decided to use that data for teaching and for all kinds of stuff that you can do. So what I'm talking about today is one software course that I held, I think 3 or 4 times now, and I've been using the openly available Opensky network data to teach aspects of software testing. So my course is called Professional Testing, and we do all kinds of testing techniques. And I do that using the Opensky flight data because it's openly available and it's easy to understand. My lecture hall is if you imagine when you look outside the window, it's in the western direction. And Frankfurt Airport is just about 20 kilometers away. So when you look out the window, you can see the aircrafts flying past the window. Some in a distance, but you can actually see aircraft flying. And so one thing is if you have actual flight data, then you can point out and say, this data that we receive right now is this plane out there on the window, outside of the window. And so it's really practically applicable to the students, and they know, okay, this is really real life data, and they know how to deal with that. So what kind of techniques do we teach in that course? Well, we teach dependency injection, behavior-driven development, end-to-end tests with TestCafe and stuff. So all the modern or currently used techniques to do software testing. So when I first started, I just had that Opensky network up here, Opensky data. And we built a very basic system like that. And when I started to run the course, then we had 20 students working at the same time in a practical lab. And when they started accessing the Opensky data, they received the too much traffic or too many requests messages. So I had the problem that Opensky data is open, but it's limited in download. Which is not really a problem because as a university, you can access the people responsible and say, well, I need more or better or open data. But I thought, well, actually, we don't need the actual live data for running the tests. What we need is some sort of more sustainable and easier to use setup. So this brings me to the first component that we built, and that's a flight data proxy. This is pretty simple. The flight data proxy just is used so we don't have the need for live data. So what do we use? What does it help us? It saves resources. We don't have network resources. We don't call the Opensky network, but we call our own server. And it also helps in setting up an independent test server. So that's really nice for this course. And what the flight data proxy does, it mimics the REST API of the Opensky network server. So the data that you receive is similar to the data, but it only uses 1 hour of data that is recycled every hour. So right now it's a little past 1 o'clock, 1:06. So if I do a request to my flight server, then it gives me the data of 1 day, and that's the 27th of June this year at approximately 13:06. So every hour I get the same data. So if I click on this link, then you should see a very familiar picture. This is the same data that you would receive from the Opensky, but it's recorded data, and also there's lots of values just blanked out because they're not used in the course. So you see many null values where the actual data would have data, but we don't need that. So that's really easy to use in teaching. Okay. So how do I get back to the other thing? Click on that. Okay, here we go. Okay. So it just uses the stored data, and it works very nicely, and students have access to this server easily. There's no restriction, and we can do all the stuff that's needed. So the next thing that we're teaching in the course, or the first real testing techniques we're teaching in the course, is dependency injection, and mocking, and rest assured. So who here in the audience is familiar with the term dependency injection? Okay. Summer, or this is really interesting. I mean, you all work in the field of flight data, and actually you're all software engineers, really. You don't know it, but you are software engineers. You work on computers all day long. You have your computers open and you try to do something with data, so you are software engineers. Dependency injection is a technique that is really, really important to help you build testable systems. Dependency injection means that you have a system that does something for you. You usually describe that using an interface. You say, this service will provide me with this sort of information. And then you make your software so that it's not using the interface directly, but that you are able to insert that part of a software that actually accesses the interface. And so you can exchange, you can actually exchange the real thing by something, what you see on the left-hand side, the test stub. So in our system, we have that flight data retrieval and processing service that uses a network access component to actually access whatever data source we have. And in dependency injection, you then exchange that component by one that is similar in the interface, but that is then used for testing the actual module that you want to test. So this technique, dependency injection, is a really, really important technique for building testable software. And so that's something that we can do and help students understand with real life data, and they understand it really nicely. So what we test is we test the flight data retrieval and processing, and we test it with a controlled test data. So the test stub here, down there, it just provides you with a controllable test data. You don't have access to the real system, so you provide access to the test system, but it behaves just the same. So what we do is we do dependency injection with the so-called test stub. A test stub, I'll go into that in a short while. Also, one technique that is really, really important in software engineering right now is test-driven development. Test-driven development is a technique where you write your tests before you write the code. And that's something that has been around for quite a while now, but it's still not very widely known. And it's really, really interesting to see students, if I tell them, write the test first, and then they say, well, how do I write a test if I don't have a software to test? And then I have to tell them, well, if you know what your software is going to do or is supposed to do, then you already know how to test it. So you write the test, and then you implement the software that then passes the test. And that gives you a very robust and a very good understanding of the system, and it helps you to have a fully tested system. So test-driven development is a technique that is really, really important, and using this test stub technique on the dependency injection really helps students to do that. They say, okay, I know I have a test stub, I know it gives this data, okay, I can write a test. I can test my component that accesses the stub. I can see if the right data is received. I can see if the data is processed really nicely. And also what we're using is Rest Assured. Rest Assured is a tool that can be used to test REST APIs, and it's really nice to use. It's easy to understand, and so that's what we do too. And there are some tough questions when you access REST APIs, and those tough questions are important to students to understand. So one question that we have is, what is the expected answer for the call? Okay, that's not such a tough question, but that's what you really have to answer. And so you write a test for that. You say, okay, I expect when I call this API, I expect this data. That's the first test you write. And so that's something that rest assured makes really easy to do. But some more tough questions are, what happens if the network connection is not working? What is your software to do? What is supposed to happen if there's no network? Okay, you have to answer that question. You have to say, well, there's a error message coming or some sort of signaling, whatever you want to do. Are there defined values for network timeouts? You have to answer that. And that's one thing that you learn when you write testable software, that you have to answer these stupid questions. Because if you don't answer them, you just say, well, my network is always available and there are no timeout problems, then your software is not going to work in difficult conditions. But it has to work. So you have to answer these questions. The same thing, are values retrieved over the network checked for errors? I'm building a client server system, so do I trust the server? What are the vulnerabilities that might be exploited if the server has been compromised? What happens? That's something that James talked before was really interesting. He says, do we trust the data? ADSB says the airplane goes 80 knots or 85 knots, and the pilot says it's 120 knots. What happens if somebody hacks your OpenSky network server and gives out wrong velocities? Are you going to check it? Who's going to check it? Yeah, you really have to think about these things, and you have to see, well, how do I know if the server has been compromised? Yeah? So all these tough questions can be partially answered, and rest assured is a tool that helps you in writing that kind of software. If you want to see a small sample of a rest assured call, you can look into my paper. It's also freely available. One detail, when you deal with dependency injection, then you also deal with mocks. Mocking is a technique that that helps you build modules that do something as a mock-up. Yeah, they pretend to be something else, and there are two different kinds of mocks. There are mocks and stubs, and that's something that my students need to learn, that there is a difference between a mock and a stub. A mock helps you to verify that an interface has been used correctly. So you see if you have called the interface correctly, and a stub is something that provides data for your test to run. So that's a differentiation that's really important to have good testable software, and you are not supposed to mix the two of them. What I also did in the course, I have used dependency injection frameworks. If you have heard of Google Juice, that's a framework that's can be used for that kind of stuff. It's really, really interesting, but it was really difficult for the students to understand the need for that. So there was just a short side note in that course. Okay, so that's dependency injection, mocking, and rest assured. One other really, really important technique in building testable software is behavior-driven development. Behavior-driven development is a technique that looks at what is the system supposed to be doing. And it's done using tests in a almost natural language, which is called Gherkin. Gherkin is just some sort of a cucumber-like thing in England. We only have one word in German for gherkin or cucumber. It's immer Gurke. In England, they have different words for the same thing. I don't know why. So the language is called Gherkin. And what you do is you write so-called feature files. And in those feature files, you describe the desired action when you do something, when you act out a behavior. And Cucumber, that's a tool that's then used. Cucumber translates this feature files into test calls or into stubs for test calls in so-called step definitions, and then it all gives you a really testable system. Okay. So how does it work in detail? We have Cucumber, we have a feature file. So this is a feature file that would just say, well, given there's no connection to the OpenSky network, when I start the application, then the return flight data is equal to whatever. So a JSON string with nothing in it. So that's something that somebody can write down and is easily understandable. And so this feature file is then translated or by Cucumber, and there are the equivalent calls now in a Java programming language, what it actually means. So there's no connection to the Opensky network. That's the same given as up here. So this is a natural language, and this is the same thing in the programming language. And the same thing happens for the then part. So you have the then part. Then the returned flight data is equal to, and this translates into this test script. And you see, okay, this looks a little bit more complicated than this, but this is easily understandable by people just writing down a test, and this is understandable by people doing programming stuff. So this is the request I do, and then the assertion that the string is actually equal is right down here. Assert equals string is data to is equal to the string that I supply and that I get. Okay, so this is how Cucumber works in detail, and that's something that my students need to understand, how to build such step definitions. And you see the thing is you can do that with flight data or with any other data, but flight data is really nice to understand. In order to run behavior-driven development, you have to have end-to-end tests, and you require a test server and a test client. And so how is this done? Well, I'm using browser testing with Selenium, and the teardown and setup is controlled by JUnit, and I use test containers. So that's a whole bunch of techniques that are used in order to do that stuff. So that's behavior-driven development. The last thing that's important for my course is end-to-end tests with TestCafe. TestCafe is a browser testing tool, just like Cypress or Selenium. Maybe you've heard of that. And it helps you to actually do tests. And we build a little sample application in the course, which just gives you this very, very simple flight position thing. And the data that's used here, it updates every 10 seconds. And the data that you see here is actually the pre-recorded data. So this is just accessing the proxy that I mentioned at the beginning of my talk. So this does not connect to Opensky, it just is within our closed network in the university. So this is really easy. And when you look closely at this picture, then you will see, well, it's worldwide, okay. But you see there's some error in the data. So what when I show this to my students, they never understand what's happening there. They don't grasp latitude and longitude, and I have to explain the world, and I have to explain coordinate systems, and I have to explain projections, and it's all very, very difficult. But sometimes, or I think it's really nice to have this view, and then you can explain stuff, and then they can really actually program this server, and then this little arrow down there disappears. One bug that is really not so obvious, and my students really take quite some time in understanding that. If you look closely at just one plane, just pick one and then see how it moves after 10 seconds. So did somebody notice anything? The heading is completely off. Okay, so why is the heading completely off? The thing is, the Opensky network gives you the heading in degrees, so it's from 0 to 359. The Open Layers API that's used to rotate the icons uses radian values. So you have to transform these 300 whatever degrees into 2 times pi. Yeah? And that's something that students see directly, and they see, okay, I really have to read the documentation. I have to understand the data that I'm using. And so this is something that you can test and that you help students understand. So this is really nice. Okay. And TestCafe is a really good and easy to use tool. It's in JavaScript, so they learn testing in JavaScript as well. And one challenge is really to have students understand where the tests are actually running. Are the tests running on a server? Are they running on their notebook? Are they running within the browser? Okay, where are tests running? And so you get them to think about what they're doing, and that's what you want in a university, that people start thinking about what they're doing. And the TestCafe tests are run within a Node.js runtime, but they control the browser, so that's something that's not so easy to understand. And this all can be handled within Docker containers, so you have the whole thing with infrastructure that you teach as well in the course. Yeah. So this is basically the setup that I'm teaching in my course. There's lots of stuff that that is running besides this obviously visible. So what I haven't talked about is the whole part of continuous integration. So doing software engineering, you have to do continuous integration or even continuous delivery or DevOps. So you have to set up the system so that it really does automatic tests. That's something that we really have to do. And also the thing is the software is configurable, so you can easily exchange the flight data proxy from using the real Opensky data. So it's a blueprint for students to start working with flight data and to get to understand that data. And it's really something, maybe I think about 10% of the students in my course really get into the spirit of that and say, wow, this is cool. Oh, I didn't know that this data was available. And then they say, oh, I could do something like, and then they start thinking what they could do with this data. And that's a really, really nice thing. And so I'm really, really grateful to the Opensky network to provide this data for free, because it's a fantastic opportunity to teach software engineering to students. Okay, thank you very much.